Let me go through the 5 steps that you'll need to find the equation of a tangent or a normal to a curve at a given point. So the first thing you need to do is differentiate the equation of the curve, because of course dy dx is the gradient at that point on a curve. And so that takes us to step 2. So you substitute the x value of the point into the dy dx term to find the gradient at that specific point, and we're going to call that gradient m. So that gradient would be the gradient of the tangent at that point. Now you only need to do step 3 if you're doing the normal. Now the normal is at perpendicular to the tangent, and so that means that the gradient will be -1 times that, and also flipped over or 1 over, whichever way you want to think of that. So for example, if m had worked out to be 2, then n would be -1/2. If m had worked out to be 3/4, then n would have been -4/3. And then step 4, again, you might not always have to do this, but if they haven't given you the y coordinate of that point, then you'll need to go back and work that out from the original equation. And then when you've got your gradient, your x and y values, then you're going to substitute those into y minus y1 equals m brackets x minus x1, or of course it might have the n outside the front if it was the normal version. And then you want to rearrange what you get into either what they've asked for as a format or something that looks nice and tidy as a format. So here we're being asked to find the equation of the tangent to the curve y equals 3x cubed minus 2x squared plus 5x minus 1 at point A, which has an x value of 1. So let's start with the differentiation. So dy dx is going to be 3 times 3, so 9x squared, minus 2 times 2, so that's 4x, plus 5. So now let's substitute in x equals 1. That will give us 9 minus 4 plus 5, which equals 10. So we know that the gradient at point A is 10. Therefore, that will be the same gradient as the gradient of the tangent at that point. So that is our m. But in order to find the equation, we need the y value to go with that. So when x equals 1, y equals 3 minus 2 plus 5 minus 1, which is 5. So now we've got all the information we need. We're going to bung that into y minus y1, which is our 5, equals our m, which is 10, brackets x minus 1. So let's tidy that up. So we've got y minus 5 equals 10x minus 10. So that will lead us to y equals 10x minus 5. This time we're being asked to find the equation of the normal to the curve y equals x squared plus 4x minus 2 at the point 4 question mark. So we don't know the y coordinate again. So let's start with the differentiation. So we've got dy dx will equal 2x plus 4. And when x equals 4, that will be 2 4s are 8 plus 4, so that's going to be 12. Now that is the gradient of the curve at that point, but the normal is perpendicular to that. So the gradient we need for the normal equation is going to be negative and 1 over, so it's going to be minus 1 over 12. We also need to know what y is before we can do the equation. So when x equals 4 will be 4 squared, which is 16, plus 4 times 4, which is 16, minus 2, and so that makes 30. So now we just put it all together. So we've got y minus 30 equals minus 1 over 12 x minus 4. So again, let's tidy that up. So I'm going to multiply everything through by 12. So we're going to have 12y minus 360 equals minus x plus 4. And now we're going to put everything on one side. So we're going to have x plus 12y minus 364 equals 0.